Welcome back to the notes for chapter 2.4. This lesson is over linear inequalities in one variable. So back earlier in chapter 2, we learned about some properties about addition and subtraction and multiplication and division of equations, and those are going to apply in similar fashion in this lesson. But instead of having an equal sign, we have an inequality sign. So this says if A is less than B, and we know that's true, then we can add a value C to A and add that same value to B on the right-hand side, and the left-hand side will still be less than the right-hand side. So let's use an example. Let's say we have 1 is less than 3. And if we take 1 and we add 2, that is still going to be less than 3 if we add that same 2. Because that means that 1 plus 2 is 3 is still less than 3 plus 2 is 5. Okay, so that means that we can solve equations using the same idea. So for example, if we have the equation of x plus 3 is greater than 5, that means that if we subtract 3 from both sides, just like we would in solving any regular equation, then we would have x is greater than 5 minus 3 is 2, which is right there. So x just needs to be greater than 2 for this solution to be true. So to check, let's say that x equals 6. So 6 plus 3 is 9, and that is definitely greater than 5. Okay, so anything greater than 2 is a solution. We're going to get practice writing solutions in number line form. So that means on a number line, if I have 0, 1, 1, 2, my answer is x is greater than 2. So I'm going to put an open circle at 2. And that tells me that I can't actually equal 2, but I can have anything greater than 2. And then I'm going to shade to the right because anything greater than true is going to give me a solution that is true. On the second page of the notes gives all of the symbols and notation for this. Then if I say that in an interval form, I'm always going to have my minimum value and my maximum value listed. My minimum value that x can be, if x is greater than 2, is it can get close to 2. It actually can't equal it. So I'm going to say that 2 is my minimum endpoint with an open parentheses. An open parentheses is the same as a circle, open circle on the number line. It says that I can get close to 2, but I can't actually equal 2. Comma, my maximum possible value is a positive infinity with an open parenthesis. Okay. Then we can also apply this with multiplication and division. So for any expression A, B, and C, where C cannot equal 0, then if A is less than B, I can multiply A times C, and it's still going to be less than if I multiply B times C, as long as C is positive. If C is negative, then it changes my inequality because of the rule that a negative times a negative is a positive, and a negative times a positive is a negative. Okay, so let's look at a couple of examples on basic ones here. So that means that 3 times x is less than 15. So I'm going to treat this as an equal sign. That means I would divide by 3 on both sides to solve for x. So x is less than 5. I'm dividing by a positive 3, and so that means that because C is positive, what I'm dividing by, it stays less than. And that's true. As long as I put anything that is less than 5 in for x, I will still have a result that's less than 15. So even if x is equal to a negative 2, right, then we have 3 times a negative 2 equals 6, and that's still less than the original 15. So X just has to be less than 5. So that means on the number line, we've got 5, 4, 3, 2, 1, and 0. And it's getting an open circle because it doesn't have any equality to it. It's just a strictly less than, and it's everything to the left of 5. And on my interval form, that means I have an open parenthesis at 5. And now 5 is my maximum value that makes this statement true. And my minimum value is a negative infinity on the left. Whenever we use infinity or negative infinity, it always gets an open parenthesis. So let's look at another situation. So here we have a -4 times x is less than 16. And if I want to solve for x, I'm going to divide by that -4. So x, and because I'm dividing by a negative, then that means I have to flip my inequality. It has to be x is greater than, and then 16 divided by -4 is a -4. So now we're saying that any value greater than a -4 will produce a true statement. And that's because multiplying and dividing by negative changes our sign. So let's draw a number line to this. So let's say we have a -4, -3, -2, -1, 0. So again, an open circle at a -4 because we don't have an inclusion symbol. And we're saying everything greater than a -4 is true. And so that means my minimum value is a -4 with an open parenthesis, and my maximum value is a positive infinity. And I'm going to put in a value that's in this space of where I think it's true. I'm going to say a -2. So a -4 times a -2 results in a +8, and that is still less than 16. So any value greater than or equal to a -4 will result in a true statement. So if we flip the page, I'm going to again show you the solution notation here. So when we present solutions in mathematics, there are a few ways to do this. We can show it algebraically in inequality notation. That's this top line here in the table. We can use a number line, that's our middle row, or we can use interval notation. And so you will see that whenever we have a strictly less than or a strictly greater than, that would be the first and third columns, then we always use an open parenthesis, a rounded parenthesis for our endpoint. And we also use a rounded parenthesis for our interval notation endpoint. Whenever we have an inclusion means we've got less than or equal to or greater than or equal to, that is the second and fourth columns. Then we use a bracket to show that endpoint. And we use a bracket also in the interval notation. So remember, the interval notation is always the max, the minimum on the left, and the maximum value on the right. Okay. So I've also given you some steps. They're from the book that I just did a screenshot for you. It says how to solve linear inequalities in one variable. So very similar to what we did solving, we're going to use the distributive property first. Then we're going to either multiply through by the LCD if there's fractions, or we're going to multiply by power of 10 if there's decimals. Then we're going to combine like terms on each side. Then we're going to use our addition property to move the constants to one side and the variables to the other. Then we're going to use the multiplication property to solve for the variable. And then we're going to graph that solution set. So on this video, I'm going, the ones that are circled are the problems that I'm doing on this video. And then there'll be a part B if you would like extra help. You only need to scan in the pages that I'm doing on the part 1 videos. The part 2 videos are just for extra support. Solve the following inequalities and give each solution in both interval notation and number line graph. Okay, so a number times a -7 is greater than or equal to 35. So we're going to pretend as if it's an equal sign, right? And then I'm going to divide by a -7 to solve for x. 35 divided by a -7 is a -5. And because I divided by a negative, I have to flip my symbol. So it's less than or equal to. Okay. And so I'm going to check my answer. So I'm going to pick a value that's less than or equal to a -5. So I'm going to say x is equal to a -8, just to pretend. So then I have a -7 times a -8. And that is a positive 56. And that is definitely greater than or equal to the original 35. So yes, I'm good. So I always do a little check on these just to make sure I'm doing it correct, because we divided by a -7, because we divided by a negative, okay? Then we have to flip the symbol. Whenever I'm solving inequalities, I always leave my x on the left too. That's just something I like to have, is I like to read x on the left. So x is something. Any other time I'm solving equations, I don't mind if my x is on the left or the right, but I like to read it left to right when it's an inequality. So I have my x on the left. So my solution set is x is less than or equal to a -5. So that means on the number line, because it's a less than or equal to, I'm going to color in my circle, and it's everything to the left of that, smaller. And then my minimum value is a negative infinity, and my maximum is a -5, and it gets a bracket. Okay, so it gets a bracket or shaded in circle, and then a bracket here. So my maximum number is a -5, and it's going to go to a negative infinity. Okay, letter B. I have a fraction, so we're going to go back to what we learned in the first couple of lessons of chapter 2, that I can multiply through by that denominator to eliminate my fractions. So I'm going to first multiply by that denominator. So I'm left with a -2x is greater than a -24. And then to solve for x, I'm going to divide by a -2. And as soon as I see that I'm dividing or multiplying by a negative, I'm going to square or circle my inequality to remind me that it should get flipped over. So x is less than a -24 divided by a -2 is a +12. So any value less than 12 will be my solution set. So that means that 12 is my maximum value and a negative infinity is my minimum value. And it's a strictly less than. So I have an open circle at 12, and then I'm shading everything to the left. Okay, so my x is on the right, which I usually don't like, but I'm going to leave it there and deal with it. So I am going to solve for x. So we're going to divide by a +4. Now I'm dividing by a positive, so I don't have to flip my symbol. Even though this is a -20, I'm dividing, the number I'm dividing by is a positive. So a -20 divided by 4 is a -5, is greater than or equal to x. Now, because I like to read my x on the left-hand side, I'm just going to write my x on the left, but that means I have to flip the symbol now because I'm moving my x, I'm flipping my x and my -5. So these say the same thing. A -5 is greater than or equal to x, or x is less than or equal to a -5. Then my x is less than or equal to a -5. That means my minimum is a negative infinity up to a -5. And a -5 gets a bracket because it has the equal sign. And I'm shading everything to the left. I'm circling that in because it's including a -5. So I'm going to pick a number that is that those numbers aren't right. A -5, it would be a -6 this way, a -7, a -8, a -9. Oops, sorry about that. That didn't look right. So I'm glad I went to check my work. So let's pick a number that's less than a -5. So I'm going to pick a -8. So say x equals a -8. In my original equation, I would have a -20. And I'm going to compare that to 4 times a -8, which is a -32. A -20 is bigger than or equal to -32. So I'm going to give that a check mark because that's what I wanted. I wanted a value that would multiplied by 4 would be less than or equal to a -20. So in this video, I did A, B, and C. So let's go ahead and flip the page. I'm going to do E. So because I have fractions, I'm going to multiply through by the number that will cancel out all of them. So 10 is a multiple of 2, 10, and 5. So I'm going to multiply by 10. So 10 times 1/2 minus 10 times x over 10 greater than 10 times a -1/5. Okay, so 2 goes into 10, 5. So I've got 5 minus, my 10's cancel, so x greater than 5 goes into 10 2 times, so 2 times a -1 is a -2. Okay. So I'm solving for x, so I'm first going to subtract 5 from both sides. So I'll have a -x is greater than a -7. I can subtract and add to both sides, and it does have, I don't have to flip my inequality. However, I do have to divide by -1 here to get x alone. And so because I'm dividing by -1, I am going to have to flip my inequality. So a -1 divided by -1 is a positive x. I have to flip my inequality. And -7 divided by -1 is a positive 7. So x is less than a positive 7. And 7, 6, 5, 4. I have an open circle because it's strictly less than, and I'm shading it to the left. And then my interval is going to be a -infinity up to a 7 with a parenthesis. Let's look at G. So G, we have some decimals. It looks like we have just one decimal place on each, so that means I can just multiply by 1 power of 10. So when I do that, they all decimals move to the right one. So I have 2, now it turns into 20, minus 7x less than 13 minus 3x. So we eliminated the decimal, and now I need to get my x's to one side. So I'm going to add 3x here. So we have 20 subtracting 4x less than 13. And then I'm going to subtract 20. I'm going to get my constants to the other side. Those are going to add to 0. So we have a -4x less than 13 subtracting 20 is a -7. And then I'm going to divide by a -4. So whenever I divide by negative, I'm going to circle my inequality. So x is going to be greater than a -7 divided by a -4 is a +7/4. So x is greater than 7/4. So that means on my number line, I have zeros over here. 7/4 is 1 3/4. There's 2, there's 3. And it says strictly greater than, so it gets an open circle and it shades to the right. And then it gets an open parenthesis in the interval form and it goes to a positive infinity. And I don't have H, so that was a mistake. So I'll do that on the review on the extra video. So let's look at I. I has a negative of this x minus 2 and then subtract 5x is less than or equal to 3x plus 7. So we're going to use our distributive property. So we have a negative x plus 2 minus 5x less than or equal 3x plus 7. I'm going to combine my x terms here. So we have 2 minus 6x less than or equal to 3x plus 7. So I'm going to move my x's to the left. And to do that, I'm going to subtract 3x so that they add to 0 on the right. And I'm going to subtract 2 to move my constants to the right. So the 2 minus 2 adds to 0. So I end up with all my x's, a negative 9x's on the left, less than or equal to 7 minus 2 is 5. And then to solve for x, I'm just going to move it up here, negative 9x less than or equal to 5. So to solve for x, I have to divide by a negative 9. So I'm going to circle my inequality. So I have x is greater than or equal to a negative 5/9. So it's greater than a negative 5/9. So that means I'm going to have a bracket because it's greater than or equal to a negative 5/9, and then it's going to go up to positive infinity. And then on the number line, I have just negative 5/9 is just below 0, and then we've got 1, 2, and so this is a bracket colored in at negative 5/9, and then everything shaded to the right. Then example 4 is solving inequalities, but we're solving for a letter. So solving for formulas. So we did some sort of formula solving earlier in chapter 2. So we're going to circle the variable that we want to solve for. And we're going to move everything to the other side. So to do that, we're going to add 3 x's. And notice that on the right, I did not write them underneath the 6 because they're not like terms. The 6 is a constant and this is a variable. So we have 2y is less than 6 plus 3x. We don't know what x is, so we can't add 6 and 3. And then we're going to divide by 2 there. I'm going to divide by 2 and divide by 2. Every term gets divided by 2. So y is less than 3 plus 3 halves x. And it's a strictly less than, and we divide it by a positive, so we don't need to flip the inequality. And we want to solve for y. So let's do D. I'm just going to circle y here. So we have 4x minus 2y is greater than or equal to negative 8. So first we need to subtract 4x to the other side. So 4x minus 4x, so we have a negative 2y is greater than or equal to a negative 8 minus 4x. And then to solve for y, we're going to divide by a negative 2, divide by a negative 2, divide by a negative 2. And because we divided by a negative, we have to make sure we flip our inequality. So we have y is less than or equal to a negative 8 divided by a negative 2 is 4. A negative 4 divided by a negative 2 is a positive 2x. So y is less than or equal to 4 plus 2x. I divided by a negative, so we had to flip our inequality. That is the end of lesson 2.4. Catch me back for lesson 2.5.